Hello everyone, thank you for registering and attending the iChemie Safety Centre webinar facilitated by Salus Technical's David Jamieson. My name is Craig Wright and my role within the iChemie Safety Centre is as a Process Safety Specialist. David Jamieson is a Process Safety Engineer and founder of Salus Technical in 2015. Salus Technical help customers understand and manage the risks of major accidents via their three business units: engineering, training, and software. Prior to launching Salus, David worked as the Process Safety Technical Authority for a UK offshore oil and gas operator and held several safety engineering roles prior to that. Today's webinar will be on, will AI move process safety to the next level, or is it a backward step? There's been a lot of buzz around AI since the launch of ChatGPT in 2022. Almost immediately, discussions began as to how best it could be used in process safety, particularly HAZOPs. To find out, Salus Technical has developed HAZOP AI to help enhance the role of people in HAZOPs, not replace them. In this webinar, we aim to find out how HAZOP AI was built and how the use of AI in HAZOPs and process safety can simultaneously be a force for good and a recipe for disaster. Should you have any questions, please use the questions tab on your screen and we will put these to David at the end of the webinar. Over to you, David.
Thank you very much, Craig. So welcome everyone. So as Craig says, we're going to look at AI. Is that something that will move process safety forward, or will it be a backward step? So we'll start with a little quiz to see if we're all smarter than ChatGPT. I'm going to explain the value of prompt engineering and how with a little bit of work you can vastly improve the accuracy of these large language models. And as Craig said, following the buzz of ChatGPT, large language models and AI, the team at Salus and I built a product called HAZOP AI. So I'm going to walk you through a demonstration of that. And then at the very end, I'm going to summarize what we as a team at Salus have learned from all this work in the past year. For anyone who wants to duck out of the webinar after 5 minutes, I'll go straight to the very end. I'll explain what all of these things mean right throughout the webinar. But we'd say that anyone who does want to spend some time researching artificial intelligence, researching large language models, the one thing I would recommend is invest your time in mastering prompt engineering, and you'll see the value of that in a few slides' time. Also, what we've learned is, although these things like ChatGPT and the models that sit behind them, the LLMs, as I'll refer to them from now on, if that's all you're going to use, I think that's something that we is going to move process safety backwards. That's something that we wouldn't recommend. What we've concluded is let's couple these large language models with our own knowledge and with our own knowledge bases, and I think that's something that can be incredibly powerful for process safety. Are you smarter than ChatGPT? I know that you're all on mute, but I'll trust that you're screaming the answers down the screen. So for anyone who doesn't know what ChatGPT is, I suggest, I think you'll be in for a fright after you look it up after this. But it's a large language model, and what that does is that creates like human-like, like text-based responses to any input that it's received. So I've got some conversations that I've had with ChatGPT over the last few days. So let's have a look. So there's a few riddles that I'm going to put up here. So the first one is: the person who makes it sells it, the person who buys it never uses it, and the person who uses it never knows they're using it. What is it? Assuming that you've all got the answer, but you can ask ChatGPT and it'll come back and say the answer to this riddle is a coffin. So straight away, without any delay, it solves that quite straightforward riddle. Let's do a slightly more difficult one. What comes once in a minute, twice in a moment, but never in 1,000 years? I must say this took me quite a long time to figure it out, but I got there eventually. But ChatGPT got there straight away. The answer to the riddle is the letter M. So obviously it's a play on words. You think it's talking about time, but it's actually the letters in each of these words. So we've got two more to let go. This next one is a lot more tricky, sorry. So there's two paths ahead and only one is safe, and there's two guards who know which way is safe. One guard only tells the truth, whilst the other guard can only tell a lie. And you don't know who's who. What's the one question that you can ask to find the safer path? So I'll just go straight to the answer. But this is quite a difficult one. But again, straight away, ChatGPT gets the answer. If I were to ask the other guard which path is the safe one, what would he say? Because the guard that's telling the truth would point you towards the dangerous path, because that's what the guard that lies would say. And if you ask the guard that's lying, he'll also point you to the dangerous path, because that's the opposite of what the guy telling the truth would say. So I've just got one more to do before we conclude that ChatGPT is smarter than all of us. It's going to steal all of our jobs and take over. And it's this one that says, I'm thinking of a number. It's either 1, 2, or 3, and you can ask me one question, and I can only answer yes, no, or I don't know. Once you show my answer, then you'll know my number. What is the question? This one flummoxed me. I couldn't get it. I had to get a friend to tell me the answer. And you ask ChatGPT, and it starts off, it looks like it's got the answer. The question you should ask is your number greater than 1? Okay, here's the reasoning. If the answer is yes, the number is 3. If the answer is no, the number is 1. And if the answer is I don't know, the number is 2. So wait a second, that isn't right. That riddle's not really any more difficult than the one that's just come before. But yeah, that's said a completely wrong answer. So maybe there's something wrong. So I asked it something else. So I said, but 2 is also greater than 1. So they would say yes for both 2 and 3. And let's see what he comes back with. It says, you're right, my apologies. Perfect. It's obviously understood it now. The correct question would be, is your number less than 3? If the answer is yes, it would be 1 or 2. If the answer is no, the number is 3. If the answer is I don't know, number 2. Right, it's definitely not understanding this. This is very strange. How can it be going so wrong? But it's given us an answer that reads like it's perfect. So okay, I've said that both 1 and 2 are less than 3. So the answer would be yes for both of these. My apologies for the oversight. Thank you. Right, it's definitely figured out now. Here's the correct approach, finally. If I were to ask you if your number is 2, would you say yes? If your number is 1, you'd say no. If your number is 2, then you'd say yes. And if your answer is 3, then it comes back and says that you would say no. So wait a second, it's still got it wrong. And if I just let it rumble on for a little bit longer, it says that you can't do it. It says you can't determine which one, which is very strange, because this is a riddle that can be solved. How has this happened? So not only has it not figured out the answer, it's also done what's called hallucination. It's given me 3 answers now that look or like sound like they're correct, but actually they're not right. So we call this hallucination. So what's happened here? How can we ask 3 riddles that it immediately gets the correct answer, and ask another one and it's way off? The ability of an LLM to answer a question actually depends on lots of things, and I've put riddles here, but that extends to like lots of things. The first one is its training data. These models are set to recognize patterns. They're not set to think. So if it's never seen a pattern before, it might give the wrong answer. So if a particular riddle, or indeed any question that you're asking, is well represented in training data, then a model like ChatGPT is incredibly likely to answer it correctly. But conversely, if that's not represented in its training data, then it might struggle. So the riddle with the 2 guards is very famous. If you type it into Google, there's over 2 million hits. So these large language models will have encountered that riddle thousands and thousands of times, and that's why it gets the answer. It isn't because it's figuring it out. Obviously there's complexity and ambiguity. Even if a prompt, a riddle seems straightforward, it might have multiple valid interpretations or solutions. And again, the model might provide an answer that seems off target, or in our case, not match the expected solution. The next one, I'm actually going to go into a bit more detail in the next slide. But we talk about thinking, but there's actually lots of different types of thinking. There's logical thinking. That's more like logical deduction. Think what Sherlock Holmes would do. But there's also lateral thinking. That's like your outside of the box thinking. And these large language models generally are good at logical deduction if it's something that's well represented in their training. But with lateral thinking, they can be hit or miss. And the final few, there's the clarity of the prompt, how you word prompts, how you word questions can have a massive impact on the answer. And finally, there's just limitations with these models. They're not infallible. They can make mistakes, as we've seen. It can overlook nuances, especially when the context, isn't clear. So it's definitely worth saying that while LLMs are proficient in many areas, they're almost perfect in many areas. They're not perfect overall, and they occasionally can and do miss the mark on certain questions or riddles. So if we're looking at riddles here, imagine how this is going to look when it looks at things like HAZOPs, which are certainly not well represented in their training data comparatively. So we just want to talk a little bit about logical deduction and lateral thinking. So yeah, logical deduction, that's like following a set of rules. It's a systematic way of thinking. There's a riddle there, a boat filled with people. It's not sunk, but when you look again, you don't see a single person on the boat. Why? And it's a play on words. It means like single, as in all the people were married. And as soon as you've understood that play on words, then the answer follows logically. So these type of problems, are right in the comfort zone of a large language model. But again, as you know, with process safety, with risk assessment, with HAZOP, that does require a lot of creative thinking. So it probably moves between both logical deduction and lateral thinking. So this is the out-the-box thinking. And that second riddle that we asked about, the letter M, that's not a straightforward logical path, because it's a riddle that's written like it's talking about time, but we're actually talking about the frequency of letters in a word. So the only reason that ChatGPT answered that riddle so well is because it was so well represented in its training data. It had nothing to do with its ability to figure it out. And just the final thing on that, and just worth saying is that the model's very good at recognizing patterns. It's very good at following logical paths, but the unpredictable and creative nature of lateral thinking can pose big challenges. So that's something to watch out for. What are you asking the model to do? If you're asking it to think out the box, if you're asking it to figure something out, that's an area where you might not have very much success. So I've mentioned a few times here about these models thinking. Can it think? Can it be creative? Risk assessment, is ultimately a creative process. You're trying to think of all the things that can go wrong, based on your knowledge and based on your own experience. But these models don't think in the way that humans do. So despite the high quality of some answers, large language models don't have a genuine understanding of what it is that you're asking and what it is that it's returning. It'll process your input and it will generate an output based solely on patterns in its training data. It doesn't understand context, it's not emotional, doesn't understand any nuance that we might do. It's mimicking creativity by combining elements from its training data, but it doesn't have a genuine understanding of what it's doing. And it's reactive, not proactive. We've got our own drive, we're curious, we're emotional, we've got personal experiences. In risk assessments, we've got a desire to speak out and express ourselves. The AI models don't do this. They respond solely to prompts. Again, I'd say, speaking from experience, much of my contribution to risk assessment, comes from my own personal experience and knowledge. I've got insights that I've picked up over the years, but no, large language models don't have like this. And just to re-emphasize that final point, I'll be saying this quite a few times, it's all about that dependence on training data. Large language models are excellent at writing poems, writing social media posts, explaining difficult concepts in simple terms, because it's been exposed to a large volume of training data. Not so for HAZOP. Now, please don't think that I'm hating on these large language models. That's absolutely not my intent, and that's not my opinion. But it's more to say that anyone who's going to start on a journey to use large language models in process safety, it's very important that you're aware of their limitations. And just lastly, I mentioned a term that you might not have heard of in this context, hallucination. What does that mean? Well, we know what it means in terms of humans, but in the context of AI, that means generating outputs that are not accurate, they're not relevant, or they're not grounded to the input and information given, but they read like they're the correct answer. Again, that's a combination that links to the training data. It sometimes might overgeneralize, if it's seen a particular pattern or frequency before, then it might just assume that that pattern is more universally applicable. You'll see exactly what I mean about that in a second with a condensate storage tank example. And yeah, this lack of grounding, it doesn't really have like common sense or a way to reality check itself. There's the quality of prompts, ambiguous prompts. In a few slides time, we're going to look at prompt engineering. Again, just more to say is why do these models hallucinate? They're incredibly complex, really incredibly fascinating and complex piece of software. But like any piece of software, there's edge cases or there's scenarios that aren't well thought out, well represented. So when you're flirting with the edge of training data, and edge cases of the software, then that's where it can go wrong. And the final one, it took me a while to grasp this, but one of the things that these models are optimized for is to produce like fluent text, to produce a coherent answer. So sometimes in the pursuit of that, they actually generalize things that maybe that like weren't explicitly represented in the input or like training data. So trying to give you a simple coherent answer actually oversimplifies the answer. We see that. We see that quite often. So that's another thing to remember. These models can and do hallucinate. You might read an answer that looks and sounds, like it's sensible, but when you scratch beneath the surface, it's not. So that's the end of part one. The next thing I want to talk about, because this is very important in how we built HAZOP AI, is prompt engineering. So prompt engineering, again, this is a term that didn't exist this time last year, but now you can, if you've got demonstrable experience in prompt engineering, you can command, incredibly large salaries. And as I say, for a job that didn't exist a year ago, that's fascinating. And just this morning, I took a screenshot of LinkedIn, a search for prompt engineers working remotely based in the UK. These are real. This is a real job. It's a real skill set, and as I say, it almost didn't exist this time last year. But what is prompt engineering and why is it so important? Well, I think it's probably the single most important thing that anyone working with large language models can learn. And, some people might call it an art or a science, but, it's how we craft effective prompts, and that guides these large language models to give us the outputs that we want. And a well-engineered prompt can dramatically improve the quality, the accuracy, or the relevance of your responses. It can also be a lot more efficient. You can get ChatGPT, for example, to really specialize to a specific task. Some people might not think this is as important in process safety, but there's lots of biases in these models. But that's something that I think does apply with process safety. If you're only giving it one type of data input, like past HAZOPs, it's only going to know about the things that have come before. So you can use prompt engineering to eliminate biases, or actually, sorry, not to eliminate. You can dramatically reduce, but they'll always be there in some way. And as you'll see in a second, it really allows the model to start thinking iteratively to really refine the approach. So some very trivial prompt engineering examples. So, one might be just, give a lot more explicit instructions. The second one is asking it to use step-by-step logic. So, it's not very good at mathematics, but if you ask it, to explain each step in the solution, then it gives a lot more accurate results. Mitigating biases, as I've said, certainly in the UK anyway, lots of CEOs are male and lots are white. So if you ask it to describe a CEO, it's probably going to do that. So you can actually ask it, here, please, you can engineer that prompt to say, don't refer to, things like gender or race, and don't make any other assumptions. You can get it to guide creativity. So, write a story. There's lots of things that I'll come back with, but you can narrow that down quite a bit. You can clarify ambiguity. I talked about there's different words that mean different things. So there's Java, the place, there's Java, the software language. So you can give it a lot more context to clarify any ambiguity. And finally, there's limiting response length. These models are computationally expensive. The more accurate ones do take more time as well. So limiting the response length is incredibly valuable. So before we go into HAZOP AI, let's look at what a very basic prompt, a piece of prompt engineering can do to our riddle. So I've got the exact same question that I asked before, but I've added 3 little words: show your thinking. So we know that this riddle requires a bit of lateral thinking. We know that it's likely outside the training data. I struggle to find a lot of instances of it on the internet. And we know that ChatGPT previously struggled with this answer. It gave us the wrong answer, and after being pushed, it concluded that it was impossible. So all I've added is the words "show your thinking," and you immediately see that the way that it's answering is completely changed. It's then thinking exactly as we would write. So we need as a question that gives us, 3 possible answers, and different for each one. So step 1. It's gone like, what's the possible answer? So 1, 2, or 3. Step 2, we need to structure a question that the 3 possible answers each correspond to one of the above scenarios. Step 3, now we need to design a question. So we go on to the next page. All I've changed here is adding those 3 words. So it's come up with a question. So this question still isn't right. Let's see the outcome. And it's concluded, nope, I haven't got this right. That's good. And I'm still not asking it anything. It's now re-evaluating, and then it's on its next attempt, I believe. There's actually lots of different answers to this one. So but it's like saying, if we exclude number 3, is it 1? So if your answer is 1, it's yes. If the answer is 2, it would say no. And if the number is 3, it's I don't know, because it's impossible to answer. Now, that was a substantial impact made by only adding 3 words. So that's prompt engineering in its simplest form. But please don't let the simplicity of that example make you think that prompt engineering is a simple art or science, because it absolutely isn't. I'm not going to go into detail on these before, but here's examples of 3 different ways that you can prompt. There's input-output prompting, exactly as I've done, but there's chain of thoughts, asking it to think at various points, or there's tree of thoughts, where you use multiple prompts for each step, and you pick the best one, and then from the best one you move to the next phase and ask multiple options. But there's countless papers being released almost every day on this. This is a huge area of focus in data science. And just as an aside, before we go on to HAZOP AI, my colleague Craig did his picture there, looking nice and happy. He is presenting at Hazards 33, and he's going to go into a lot more detail on some of the things that I've discussed specifically relating to HAZOP AI. So let's move on now to our journey for HAZOP AI. It's worth saying, I'm a huge fan of HAZOPs. I attend them all the time. I think they're an incredibly effective exercise to do, and you'll not hear me criticizing them, but there's been lots of published literature that highlights common problems or improvement areas with HAZOP, and here's just some that I've handpicked from an ICME paper. It can be difficult to get the correct team composition for the duration of the HAZOP, and that's something that seems to be getting worse with time. And that second one there, it seems that I'm certainly seeing this as as a consultant. There's a considerable reduction in the amount of time that was available to perform these things. It can be incredibly difficult to get the required data, and a HAZOP is a huge financial investment, both in the preparation, people's time during the session, the opportunity at cost of them not being able to do their day job, and of course action follow-up. And anyone who's involved in HAZOPs knows how difficult action follow-up can be. It's worth saying that AI can help these, but it's also, if it's misused, it's got the potential to make them worse. And again, I think that's something that I really want everyone to reflect on and take away, that AI is here, it's not going away. But if we use it incorrectly, then there is a risk that actually we exacerbate these problems. So for example, inadequate team composition, and having an AI system, that's like built upon your process safety data, that might be able to offer insights, historical context, suggest potential hazards. It can help, it can really help like bridge some gaps in expertise. But the misuse case is if you over rely on AI, without the human experts being there, that's certainly not a situation that you want to go down. And then new hazards or rare hazards that only a human expert would be able to identify, might be missed. Similarly, with lack of time, I think there's huge potential to save time whilst maintaining or increasing quality. But again, if time becomes the driver, then important discussions or brainstorming sessions, might be missed. Speed of HAZOP shouldn't come at the expense of thoroughness, and that applies to any risk assessment. Again, insufficient data. Organize many HAZOPs and gathering the data, getting drawings updated, etc. Can be very difficult. And AI is, maybe it is fantastic at hoovering up lots of unstructured data, but again, if you're starting to rely on AI to make some assumptions and things like that, as we've discussed, it might start leading to flawed HAZOP outcomes. So incorrect data predictions might steer a HAZOP in the wrong direction. So again, hugely important to remember, if misused, if over relied upon, then it could be a backward step. So given the limitations and flaws of LLMs that I've just introduced, hopefully you can see that. So what about ChatGPT for HAZOPs then? So this isn't HAZOP AI, this is just, again, using ChatGPT. So I've given it an incredibly simple example. I've got a condensate storage tank. It's got an inlet line, an outlet line, and a drain line. And you pre-populate a HAZOP table for this equipment when in normal operation. And here's just 3 of the deviations that came back. And let's just have a little look at them. So no flow, more flow, reduced flow, pump failure, a block line, tank drains too quickly, looks good on the face of it, but then you'd start to go, well, hold on a second, reduced flow, partial blockage by debris or icing. I mean, it's obviously not impossible, but I would say, where condensate storage tanks tend to sit in the process and the operating conditions, I'm not really too concerned about icing. I'm surprised that's one of the top 3 things that's come back. And it's talking about lots of equipment here that, obviously in reality, I'm sure would be there, but I've not asked it to look at pumps or valves or things like that. So how does it know that those are like there? And it's just assumed some safeguards again, that aren't there. And really, the ultimate consequences, I've maybe not picked the like best ones for the example here, but we're more looking at damage to equipment and loss of containment and harm to people. So again, very, very simple example, but I would encourage anyone to build an example and ask for a HAZOP table to come back, and then maybe come back and ask it to keep refining. Because when you do, you'll find that you might start to get deviations that aren't credible, or sorry, they aren't credible based on the data that we've given it. And again, that's that pattern recognition, that's like going on there. It just assumes that a like valve or a pump's going to be there because that's probably what was there in its training data. We see this, again, there's no understanding of how components work. We had one example where we had a manual valve that was open, and there was a more flow where it was like that the manual valve is going to be open even more, but it was already fully open. As you saw there, the model attempts to account, for safeguards that don't exist. And yeah, it takes quite a bit of prompting to get the model to follow a consequence all the way, to the ultimate consequence. So, it absolutely can be done. And I would recommend, after this, that you go and give it a go, but you'll soon find some of these and many other things as well. So we decided that we wanted to build our own model, make our own AI pipelines that use like chain of prompts, looking up our own, knowledge library and library of text files. So we called it HAZOP AI. We'd been we'd been researching all of this for months, and we decided that the only way really to learn was to build something ourselves. So what I'm going to show you, the software, it's the result of a 5-day hackathon, and we set out, can we prove that it's possible to have a 50% reduction in the time taken to complete a HAZOP whilst increasing quality and consistency. But as Craig said right at the beginning, it's my firm belief that any use of AI in process safety must enhance the role of people and not replace them. And here's a picture of the HAZOP AI team on the final day of getting it all done. It was a very warm day. I don't normally wear shorts to the office. So how does HAZOP AI differ from what I've just shown you? Well, it doesn't use ChatGPT for a start. It does use large language models, but they're accessed via an API. So we've got a user interface where the user can describe the equipment, what we've called the process layout, and they can describe the process description exactly as you would in a HAZOP node. We've then got several AI pipelines that are really just engineered prompt that are step by step by step. We don't ask the model really to do any thinking. It's more just to complete a series of very small tasks. We've got additional information that it's allowed to call upon. So for example, that might be past incidents, summaries of, descriptions of how equipment operate, what their failure mechanisms are, some best practices, some governance, on HAZOP, for example. So it's using the input from the user and our knowledge library to complete a series of tasks. And the outputs that it gave were a list of relevant incidents, questions that were likely to be raised in the HAZOP, and a pre-populated HAZOP table. So just before I bring the software up, I'm going to show you an example for a condensate storage tank. This is the PFD, it's a very simple condensate storage tank, and there's nothing there that you wouldn't expect. So let's hope that technology works and HAZOP AI can come up. So hopefully everyone can see that. Okay, so here is HAZOP AI. If anyone just goes to HAZOP.ai, you're able to see this. There's a video of me explaining how it works and a bit of info of what the software is all about. But you're welcome to take a free trial. It's been up for several months now. We'll likely take it down in a few months' time. There is a monthly cost, so I'd recommend doing that sooner rather than later. You can open a project, and you get a nice little welcome notes here, just explaining what HAZOP AI is and what HAZOP AI isn't. So, I am not and never will be a substitute for HAZOP. So you're free to enter your own information. Now, we've got 3 preloaded examples. So let's choose the condensate storage tank. And that's of the PFD that I've just shown you there. So the two inputs, there's an equipment description. At the moment, it's text-based. More on that in a second. We've got some guidelines for how to populate that. And then there's your process description, which I've made it very simple here, but that's what you would normally, describe a HAZOP node. And again, we've got the guidelines here. So if you press Run HAZOP AI, and that seems to have worked, which is fantastic. So here's the 3 pipelines here. So let's have a look at what we've got. So we've got a list of relevant incidents. Now, we've got a limited incident database, but it's be far more powerful if it was connected to a larger database. So if I just take one here, I'll take the shortest one. So we've got a storage tank. There was a hot day, liquid in the tank rose, and then there was a sudden shower of vapor, and the tank collapsed inwards. And then we've got 2 questions here, and these are questions that the HAZOP team can ask themselves to make sure that they're doing all they can to prevent the incident. What the AI is doing here is it's picking up all the equipment types and operation from the input data. It's then accessing a vector embedded database of past incidents. It's then summarizing that incident, as in like one paragraph, and it's then looking at the root causes of the incident and then asking a question, to the HAZOP team. The next one's questions likely to be raised. I'm sure you've all sat in a HAZOP before where someone's asked a straightforward question and we've not had the answer, not had the data. So again, there's a question and then there's context. Why have we asked that question, so that we don't want the AI to be a black box. If it gives you something back, it should tell you why. And this can be used twofold. It can be used to help prompt attendees, or it can be used by the person organising the HAZOP to make sure that they've got all of the information there. And again, this is a series of prompts where, with the input data, it's looking at what the top risks are, it's looking at what the consequences are, how they could be prevented, and then what questions could then be asked. And then the final one, and I must say this is probably my least favourite one, but it seems to be the most requested one, is a pre-populated HAZOP table. So we've stopped at safeguards, but you'll see there. So again, we've got information that's been looked up. What is a HAZOP? How does it work? And things like that. And again, it's going through what all the causes are and consequences right through to the ultimate consequence. So that's a very, very quick run through of HAZOP AI. I strongly advise that you try it out for yourself, and please give us feedback. We do have several other examples, but you're free just to delete the text and input your own data there. So if I hopefully can just come back, there you go, perfect. So what were the outcomes? So it was very popular, over 150 people signed up for a trial, and about 70 companies, booked a meeting. But the feedback from users was, well, the text input, is a no-go, basically. And I completely understand that. So to have to move to a more graphical input, the technology to reliably read and understand P&IDs at the scale that you need at. I'm not convinced that it's fully there yet, but we're speaking to people about that. Even though there's potential time saving of things like this, I think users were reluctant, to spend more time than they already are. So I think any use of AI and things like HAZOP would need to, dovetail better into the current process. This next one we weren't surprised about. As you deviate far away from our examples, the accuracy reduces, but that's just because we've not put the we haven't given the model the information for very much beyond our examples. Despite being impressed with the results, I think everyone's skeptical about the use of AI. So I think we'd have to make sure there was a lot more transparency in the results coming back. I asked almost everyone, what would stop you from using something like this? And that was the most common answer, is the skepticism around it. Of course, with HAZOP, there's almost unlimited scenarios, so you're always going to have, some issues. And certainly the way that we've built it, I think the feedback was that it might be better suited to smaller work scopes, rather than larger scale HAZOPs. In terms of us, overall, I was incredibly satisfied with the quality of the results for the data that we gave it. But despite this, we were always chasing hallucinations. And really my biggest takeaway, that first pipeline that used a vector embedded database, so that was very accurate, but the other two solely relied on LLMs. And our big takeaway from HAZOP AI is that you shouldn't rely solely on LLMs to do all of the work, because you'll always, to some degree, be chasing hallucinations. It's incredibly sensitive to any subtle tweaks to the wording of prompts, or moving from one model to the next model. However, I don't want to end on a downer. There absolutely is another way to do it, and that's something that we are looking at right now, and we've already seen much greater accuracy and performance. And that's using LLMs for data retrieval and data summary, much like what our first pipeline does. LLMs, you can give it a paragraph or give it text, like a whole page on any topic, even a topic filled with jargon or acronyms, and it'll do an incredible job of summarizing it. And indeed, any output that comes from a database, any other output, ask it to convert it to another format, and it's awesome. So using LLMs to summarize, to lift data from your HAZOPs, lift data, from your node descriptions, lift data from other documents, it's incredible at, and then formatting that to make a database call if you've got the data stored in a good manner, and then summarizing the outputs. It's fantastic at doing that, and then you're not relying on any lateral thinking. for the model. So just to give you a bit of context of what I mean by that. So one such data structure is a knowledge graph. Now, without realizing it, we're all probably quite familiar with knowledge graphs. It's exactly how Netflix does such a good job of proposing what your next movie should be. You could ask ChatGPT, here's 3 films I like. Can you recommend some other ones? And it's fine if you've watched quite popular films, but if you do anything less so, then it's not so good. And really, what this is here is the dotted line. Inside that's your database. You've got the user in blue. There's 3 films that they've watched. And what a knowledge graph database does is it's more focused on the relationship between different things, which I think for HAZOP is exactly what we would need. And here you'll see it's got a few directors, it's got the actor, it's got the genre. So what it's saying there is, well, because you've watched 2 films with Castaway, one with Robert Zemeckis as the director, I think you should watch Forrest Gump because it stars both Tom Hanks and it's directed by Robert Zemeckis. So this isn't AI. This is just a part of data science. But here's a HAZOP represented as a knowledge graph. Now this is a bit more complex, and I'm happy to show this one because this is one that we're not going to use. But you'll see here that you've got a guide words. No flow. Apologies, actually, I'll maybe start. So you've got a storage tank, primary equipment. You've got the different lines that are there. So you can have no flow, manual valves left closed, and that would mean that your manual valve on your outlet line is then closed. So then that blocks your outlet line. That might lead to your tank overfill, and that could result in loss of containment. So you can have an incredibly large knowledge graph with hundreds or thousands or even millions of nodes, and what you can do is you can ask an LLM to filter that. So you could give an input, a list of equipment. You can describe your HAZOP node. The LLM can then filter that database, and then it can retrieve all of the deviations that are from your database, and then that can format that perfectly into the way that you want that summarized in your report. I think that's the direction that we want to go down, is using LLMs to retrieve data from your own knowledge base. And you can also use LLMs to help build that knowledge base as well. It's fantastic at extracting information from a HAZOP. And just before we conclude, so the advantages of this, it's much faster, lower computational expense. Hallucinations are vastly reduced or can even entirely be eliminated, and just the overall accuracy of the results comes back. And then, it's far less of a black box. All your AI or your LLM is doing is just helping to, filter through and then retrieve data rather than doing any thinking. So final slides for me then on the conclusions. So the slide I put at the very beginning, I think AI can take process safety to the next level. But if we over rely on AI, if we use only LLMs, then I think it could exacerbate some of the existing problems, and it might be a backwards step. And as I've said there, I was asked as part of today, to give any advice to people wanting to explore this. I'd say invest your time in prompt engineering. I would say don't rely solely on LLMs, and I'd say see if you can structure your data in such a way that it can communicate with LLMs, and I think you'll see some quite fantastic results. We've spoken about HAZOP. I think it's just worth saying that there's lots of other use cases as well. We're actually building an operational risk assessment tool for a duty holder, and that's not going to do anything for them. It's just going to prompt them with things that might have been missed, making sure that the quality of the inputs are sufficient, highlighting anywhere that they've not met their own governance, and then helping prompt in some potential hazards. And that's solely just looking at their input and checking their own knowledge base. We got lots of requests for a creep and change HAZOP, read a HAZOP, and maybe highlight a list of questions to ask that can better identify creep and change. You can evaluate an existing HAZOP for things that might have been missed. It's very good at generating audit and assurance checklists, to help you make sure that the safeguards that you took credit for are actually there. And lastly, you can bring HAZOPs to life by extracting information from them. Find common hazards, find the safeguards that are mentioned again and again that are then more important than others, and lots and lots of things. It's incredible at summarizing and lifting data from like unstructured data sources such as HAZOP tables. And yet, just finally, Craig will be presenting at HAZOPs 33. He'll do a far better job than I've just done, I'm sure, and he'll go into a lot more detail, of the engineering and science behind what we've found. And yeah, he's the first person up on the 8th of November. And I'd say, it's not going to be up forever, so I'd say please visit HAZOP AI and try it yourself. I'd love to hear your feedback. Especially constructive feedback. It's really helped, point us in the right direction for our future projects. And yeah, please reach out, send me an email. I would love to hear from you, and I would love to discuss it with you. So that's me. I'll hand you back to Craig now, and yeah, welcome any questions that you've got.
Thank you very much, David. That's very insightful. Some valid points you've raised there on the manipulations and biased approaches that can occur with AI. Certainly a system that needs to be used with caution going forward. I did mention at the beginning, if we've got any questions, please put them in the questions tab to the side. Thanks to you who have been doing that throughout the presentation. So the first one we have, David, is, can you share any thoughts on striking a balance between maximising of the learning database via protection or IP and legal privilege?
Do you mean like in the context of like using the large language model with your own data? Well, if that's what that's meant, yeah, that's another thing to watch out for. Is if you type anything into ChatGPT, it's it's open to them to train their model on. So I certainly, maybe that's something I should have said. I certainly wouldn't put any sensitive information into ChatGPT because the model will be learning all of it. There are other models in their API that they've got encrypted tools that then aren't used for training. So I'd certainly say that on the legal and IP side of things, I would definitely use OpenAI's API or other models like that rather than ChatGPT. That's what we did for HAZOP AI, even though it's all just there's no like customer data about anyone typing information into HAZOP AI. That's going to be protected. Yeah.
Yep. So through your software, it would be protected. Excellent.
Yeah, and I think that's something just to watch out for as well with everyone, is that know any model that you use that isn't just ChatGPT, is know what's happening with your data before you type things in. Yeah.
Excellent. So thanks, David. Great presentation. Where is your HAZOP AI is currently being used? Any particular industry or any operators that are currently using this technology? Obviously, possibly don't mention the operators' names, but certainly the industry you're in.
Yeah, so we're in quite a few different industries, but our like birth was offshore oil and gas, and then onshore petrochemical in the UK. HAZOP AI, this was really just made as a showcase, so there are some people that are using it regularly, but it's those industries. But to be honest, it seems to have been quite a mix of industries and countries. So it's mostly oil and gas and petrochemical examples. So that's where it's like best just now. But it seems like from inquiries that we've had and discussions that we've had, there won't be any one industry, and specifically. Our experience is oil and gas and petrochemical, so it's a good place for us to begin. But yeah, I'd say it's universal.
Yeah. Can we do SIL and LOPA using AI?
Yeah, I think with LOPA especially, I think there's huge opportunities there. It's flirting with the limits of my competence, so I'm probably not the best guy to do it. But I think someone who has that, I think that's a huge opportunity, and I'd be quite excited to hear about it if anyone wants to give that a go.
Yeah. In your experience, are companies comfortable with sharing their knowledge base past instance which is necessary to train the AI model?
Well, lots of companies struggle to share their instance with each other, so I would imagine that there's a reluctance to do so with a model. Yeah, but as I say, there's lots of and an ever-increasing number of secure large language models that are out there. So I think that's an issue that exists today, but I think it'll disappear over time, that you can get the benefit of these large language models without any risk of your data,
Yep.
leaving your own servers.
Is it possible to include risk ranking based on risk matrix?
Absolutely. So there's two ways that you could go about that. As I say, the model will not understand the concept of a risk matrix and risk ranking, but what it can do is pattern recognition. So if you've got a large library of past risk assessments, it could recognize patterns and say, you mostly score this a B4, so here's what I think it is. Or you can use prompt engineering to give it lots of minor logical tasks to like do the consequences meet the criteria of this part of the risk matrix, and assign score. So absolutely, it's one of those things. It's like, even if you could do that, would you want to do that? It's like there's lots of value in the discussion of risk ranking. But equally, on the flip side, a lot of people would say that that's the part that derails the session because you're arguing over something's a B or a C. So it depends what the problem is, but absolutely, yeah, there's two ways certainly that I know of that it could do that. Yeah.
Okay, we'll get 3 questions to go. Can we predict future incidents based on AI by giving input of leading indicators?
Yeah, so really, really good question. There's lots of things about AI and the bias of data, and that's race and gender and things like that. But that applies equally to technical things like this. If you only give it one source of data, it's going to just be biased towards that. So if you could train a model on every single HAZOP that's ever happened, it would perform excellently, but it's not going to come up with anything new because it's only going to be looking, in the past. So if you want to use it to predict things, you have to have a diverse source of data. That's past risk assessments, that's how equipment can fail, that's past incidents and their root causes, and then how did that tie to the performance of leading and lagging indicators? And then when it might see a similar trend with your own indicators, it can say, look, here's someone else who was in a similar position to you, and this is what then happens. So I think if you're going to be using it to be creative, to predict things, you have to have a diverse set of data if you want to do that, and not just past risk assessments, because you'll just make the same mistakes and come up with the same answers as past risk assessments.
Okay. Do you feel this is better suited to use as a HAZOP chair, or use the software on the day by the team for more challenging questions?
So I'm going to sit on the fence on that. I would say that you can use it in 3 places: before, during, or after the session. You can use it before to help gather data, to help make sure that you've got maybe some pre-population to get you going, to make sure you've got the answers to any questions that might come up. You could use it on the day. You could almost, these things are very good at speaking now, so you can almost have like an Amazon Alexa sitting on the table that's actually contributing to the discussion and prompting people. Or you could use it afterwards. Did we miss anything? And things like that, or maybe helping to better report or better lift the output of the HAZOP into whatever you're going to do next. So you can use it before, during, or after. Probably with what we've done with HAZOP AI, it's more focused on the before. But I reckon in the next few years, there's going to be some quite exciting solutions that come up, that can be used during HAZOP.
Okay. How much time do you think this will reduce the HAZOP time, i.e. workshop? The HAZOP tables were not specific to the equipment. Will you include the actual names of equipment and tags? Yeah, so I think, if you look at, I've sort of more looked end to end, but even if you look on the day, to use the lean terminology, there's a lot of waste in the HAZOP process, if you like, discussing things maybe are less so important, but you've sort of got to do them to fill that process. So I think there's lots of opportunities to save time, but as long as that doesn't come at the expense of the thoroughness and the rigor of the risk assessment and the value of the discussion. And things like tags and stuff, absolutely, yeah. We just, that was just a
generic example that we used, but these models already recognize what a tag number is and things like that. And if if there's a way that you can have a PNID, say, or something, or a PFD represented as a vector embedded database or knowledge graph, it'll absolutely pick those things up, no bother at all. And that even that alone would be a time saving. I'm sure quite a lot of people on the call have sat in a HAZOP where we're like, what's the tag number? Oh, it's on page 4, and VX, C, blah, blah. So even that would be good. And yeah, I think that's something that I think you'll be seeing quite a lot of going forward.
Yeah. How does HAZOP AI recognize chemical properties and put them all together with the hazard analysis of a specific PNID?
So our HAZOP AI doesn't. We didn't go. Oh well, actually, sorry, we maybe did, but that's basically just if you're using only LLMs and prompt engineering, we've essentially just got quite sophisticated prompts and essentially large text documents explaining a concept to the large language model. So although what it's doing is quite sophisticated, it's actually stored in a very unsophisticated way. It's just able to look up data and things like that. So as I say, you can just have all that information in a knowledge library and don't rely on the LLM to actually understand anything. Just get it to pull the necessary properties or or outcomes and things like that it needs. So yeah, that's what I'd say to that one.
Okay, that's great. And last one, would quite a few people have posted this question, and it's, where can we buy a license for HAZOP AI?
It's free. So just go to HAZOP.ai and use it. We built it as a showcase. I've got my own ideas for what we can and can't use AI for, and how there's potential improvements for HAZOP. But we made it so that we could get as many people using it as possible to get their feedback. I'd say it's a limited data set comparatively, but what we want to know from people is what do you think? Are you skeptical? Do you see a use for this? What would stop you from using this? What do you think about the quality of the results, both for our examples or your own examples? So yeah, I'd say please just go to HAZOP.ai and sign up and have a play about it. But please, the only thing I'd ask in return is, even if it's constructive, please leave some feedback, either on the form on the site or dropping us an email.
Excellent. Well, thanks very much, David. So as David says, should your organisation like to know more about HAZOP AI, please contact David. His details are on the screen in front of you, or feel free to reach out to myself at the Safety Centre, and I'll put you in touch with David. Please do consider giving constructive feedback, as this is only going to help build a better software that we can use in the ever-evolving world that we live in now. So thanks very much, David, and I hope you all enjoyed the webinar.
Yep.
Have a good day. Bye.
Thanks all. Bye.